We'll continue with these problems where we're trying to identify the intervals, the open intervals on which functions are concave up or concave down. Let's jump right in with number 11. 11, we have f of x is equal to 24 over x squared plus 12. Now this one I probably would rewrite this as 24 times x squared plus 12 to the negative 1, since it's not going to involve either a product rule or a quotient rule. We go for the first derivative, and that is negative 24 times x squared plus 12 to the negative second, but I do have a chain rule here. I'll have to multiply by the derivative of the inside, which is 2x. Simplifying, I get negative 48x times x squared plus 12 to the negative second. Now, I'll go on to the second derivative. I don't stop at the first derivative when I'm looking for concavity. This time I will have a product rule, and so it's 1 d2, that will be negative 2 times x squared plus 12 to the negative third times the derivative of the inside, which is 2x, and that gives me my 1 d2 plus 2, which is x squared plus 12 to the negative second power times the derivative of the first, which is negative 48. Right, I need some simplifying there. I have, with the first part, 2 times 2 times 48, so that should be 192, and negative times negative is positive, so I have 192 x squared, then x squared plus 12 to the negative third, then minus 48 x squared plus 12 to the negative second. I want to factor out my least common multiple, which is always the smaller, x squared plus 12 to the negative third. That leaves me 192 x squared minus 48 times x squared plus 12. What power do I need? I have negative 3 plus what gives me negative 2 is just 1. So I have x squared plus 12 to the negative third, then that is times 192 x squared minus 48 x squared, then minus 48 times 12. It's okay if you reach for your calculator there. And 48 times 12 is 576. So we have one more round of simplifying here. X squared plus 12 to the negative third power, and that is 192 minus 48, which is going to be 144. So 144 x squared minus 576. Now, most of this is just plain old algebra or arithmetic even, and we need to simplify that 144 x squared minus 576, see what is the greatest common factor of those two. Well, both of those are divisible by 6, so if we begin from there, I'll let you figure this out on your own, and I'll just figure it out here not to waste time on the video. Or should we? Let's just have a review of some basic math. 144. I'm looking for the greatest common factor between 144 and 576. I know that it's at least 6. If I did a factor tree here, I have 12 times 12, which is 2 times 6, which is 2 times 3, 2 times 6, 2 times 3. So the prime factorization of 144 is 2 to the 4th power times 3 to the 2nd power. 576. I know that that is divisible by 6, so if I start there, and 576 divided by 6 is 96. 6 is 2 times 3. 96, that would be 2 times 48, I believe. And 48 is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So my prime factorization for 576 is 2 to the 1, 2, 3, 4, 5, 6th power times 3 to the 2nd power. And so we take one of each factor and we find the lowest of each, and so that becomes 16 times 9, which is 16 times 9 is 144. So I guess 576 then is just 144 times 3, or 4. 144 times 4, exactly. Alright, so we have our new value here, and I'm going to go ahead and erase all of that there. And we now have 144 factored out. That's x squared minus 4 over x squared plus 12 to the 3rd power. And this is our second derivative. We'll go ahead and one more time we'll factor 144, x plus 2, x minus 2, all over x squared plus 12 to the 3rd power. Now, you recall, this is our second derivative, that a rational function is 0 when its numerator is 0. So we have two potential points of inflection here, x equals negative 2, x equals positive 2. We don't have to worry about the denominator. In this case will never be 0, and we're going to make our number line and put in our potential points of inflection, find test points. Remember that we're working with the second derivative here, and we're just going to plug them in. The denominator, because it's x squared plus 12, will always be positive, so we only need to worry about the numerator and those two factors, x plus 2 and x minus 2. Plugging in negative 3, I get negative times negative is positive. Plugging in 0, I get positive times negative, which is negative. Plugging in 3, I get positive, positive, which is positive. So our job was to find the intervals where it's concave up, and that is from negative infinity to negative 2, and then from 2 to positive infinity. Concave down is from negative 2 to positive 2. Again, if you wanted to, you could go in here and draw the little up and down concave segments to show you. Now, we haven't gotten to this point yet, but we do have 2 points of inflection. X equals negative 2, x equals 2 are points of inflection, because concavity changes from positive to negative at x equals negative 2, negative to positive at x equals positive 2. So x equals -2 and 2 are both points of inflection. So we only got to do number 11 here. It's a lot of work involved in that, but we'll go on to number 13 in the next video.